Okay, stats, elementary stats. We're gonna walk through that first packet of notes that I gave you. So the first one, just talk about a few topics in section 2.2. Looking at lower class limits. That's just the smallest numbers that belong to a class. Upper class limits, the largest numbers that belong to a class. Your class boundaries will be numbers that are used to separate the classes without any gaps. Okay. Class midpoints, values in the middle of the classes. And then your class width would be the difference between two consecutive lower class limits or upper class limits. So we have this example right here. Um, each one of these categories are classes. 50 to 69 is a class, 70 to 89 is a class, 90 to 109, 110 to 129, and then 130 to 149 are your classes. And here we have frequencies. In other words, we don't know what, according to this data set, we don't know what data values are that actually show up in out of those classes. We just know that two data values are between 50 to 69 inclusive. 33 values are between 70 to 89. 35 between 90 and 109. 7 data values, excuse me, between 110 and 129, and then one data value out of the data set is between 130 and 149 inclusive. So we don't know exactly what they are. We just know how many data values show up or fit these categories, these classes. So your lower class limits would just be 50, 70, 90, 110, and 130. All of your smaller values, smallest values in your classes. And then your upper class limits would be the largest values in your classes. Class boundaries, where you calculate them, is you would take your consecutive lower class limit and upper class limit, add them together, and then divide by 2. So that's how we got the 69.5, 89.5, 109.5, and so on. If you want to extend past that, you take the 149 and then 150, add them together, divide by 2, or go to the lowest value possible or the lowest class boundary possible. Take 50 and 49, add them together, divide by 2. So that's how we got 49.5 and the 149.5. Class midpoints, add your lower class and upper class limit of the same class, add them together, divide by 2. That would be the middle value of each one of your classes. Your class width, all you do is take two lower class limits or two upper class limits consecutive and subtract them from each other, and you will get that class width. So here I chose 70 and 50. So I could have done 70 and 50, 70 and 90, 110, 130, either way. Subtract them from each other, you get 20. Or if I did 69, 89, 89, 109, and so on, you would still get that 20. It'd be your class width. When it comes to your normal distribution or the distribution of your data set, the first one they give us is the normal distribution. I put asterisks beside it because this is the one we're going to lean on the most as we continue to progress throughout the course. Your bell-shaped curve is symmetric about the mean. Our mean will be in the middle. You'll see that as we go throughout. It is considered your normal distribution. Uniform distribution is when it's all distributed uniformly or evenly. Skewed left is when your tail, the tail of your data, or the least amount of your data is to the left. And skewed right is when the tail is to the right. I know to me, when I say skewed left, it sounds like you're saying that your data is pushed to the left, but it's actually the opposite. Your data is actually pushed to the right, and the tail of your data will be to the left. And if it's skewed right, the tail of your data is to the right, and the bulk of your data will actually be to the left. All right, stem leaf plot. The leaf is going to be the rightmost digit of your data values. Your stem will be all the values that precede the rightmost digit, or all of that data values all of the values that precede the leaf. So if I have the number 53, your leaf would be 3, your stem would be 5. If I have 127, your leaf would be the 7, and the 1, 2, the 12 that precedes the 7 would actually be your stem. So if I have this data set right here, the first thing I'll recognize is what is my lowest value and what is my highest value. That will tell me how far and how I will go as far as my data set is concerned. So I'm going from the 40s to the 110s. And I got 4, 5, 6, 7, 8, 9, 10, 11. All of those represent the tens values. And then my ones would be to the right. So 41 would be 4, and then a 1 is a leaf. I have 50 and 60, so I will use 0 and 6. Notice there are no 60s anywhere, so I don't put anything for that. I can't put 0 because number 0 represents number 60. 71, 72, 72 two twice, and then 5, that would be 1, 2, 2, 5. And you just keep on with that same pattern, and you would create your assembly plot. All right, so that takes us into chapter 3. Remember, if you have any questions about chapter 2, majority of chapter 2 were definitions and graphs. So if you have any questions, make sure you contact me. But there were just a few things that people have had questions about in the past, so I just went ahead and talked about them in that packet. So going into chapter 3, at least the first section of chapter 3, measures the center. Your mean is just another word for average. You calculate it the same way you would calculate your average. So you add all your data values, divide by the number of data values. So if my data set was 1, 2, 3, 4, 5, you add up those data values, which would be 15, divided by 5, and your mean or your average would be 3. Your median, your middle value, your range of data values from least to greatest. A lot of times people forget that step, so make sure you hold true to it. Arrange your data values from least to greatest. If the number of data values is odd, you take the middle value. If the number of data values is even, you'll take the mean, the average of the two middle values. So if you have a data set that's 1 through 5, there's an odd number of data values, so it means you actually have a middle value. And so you take that middle value, which would be 3. If your data set was 1 through 6, you don't actually have a middle value. So you take your two middle values, add them together, divide by 2, and that would be 3.5. And that 3.5 would be in between your two middle values, which is a 3 and a 4. The mode, that's the data value that appears the most frequently. It is possible to not have a mode, and it is possible to have more than one mode. Having 2 modes is bimodal. Multimodal would be more than 2 modes. So if I had this data set, the number that appears the most frequently would be the number 7. So 7 would be the mode. Your mid-range, the largest data value plus the smallest data value divided by 2. So in this data set, 1 through 7, I would take 1 plus 7, add them together, divide by 2, and 4 would be my mid-range. All right. So also in this book, it doesn't really call for you guys to know the process of calculating the standard deviation or the variance. So what I tell you guys to do is to find an app, website, or calculator that will be able to calculate those things for you. EasyCalculation.com is one that I know for sure works the best. I mean, not necessarily the best. I mean, it just works well. So EasyCalculation.com is one, but you don't have to lean on that. You can use an app, any app, website, or calculator to calculate the standard deviation variance. All right. Let me know if you have any questions.